Lesson 8.5, Day 2, we are going to be adding and subtracting with unlike denominators. Now I know we have lots of steps in order to add, subtract, multiply, and divide, but these steps are going to be new, so it's important to have these in your notebook. Please pause the video, write out steps 1 through 7, and then press play, and I'll kind of talk through maybe some things to add before we get started with the questions below. To add and subtract with unlike denominators, the key step right out of the gate is step 1. We're factoring just the denominator. And then we're going to state restrictions in the domain. So this is the only time we have to do that. You'll notice at the bottom there aren't any like restrictions again. And then we're going to tie in with what we talked about in day 1, find the least common multiple for the denominator. So AKA the LCD, least common denominator. And then what we're going to do is convert each fraction. This is a big work step. So this is a big step that's going to be new to us with this lesson. And now when we have that, then we combine our numerators just like we did in day 1. And it's not until step 6, everybody, that we actually factor the numerator. And then last but not least, and this is going to be hard, this is the only time we reduce. So we're going to wait to reduce until step 7. And I'll show you with some examples when you might want to try to reduce earlier, but wait to reduce to here. All right, let's give a few examples a try. Example A, we're going to find the sum of 3 over 4x plus x over x plus 2. In step 1, we're supposed to only factor the denominators. Well, notice I have 4 times x. Nothing's being added or subtracted, therefore nothing factors. And in the second fraction, we have x plus 2. Nothing factors. In this example, step 1, we don't have to do anything with it. But we do have x's in the denominator, so step 2, we need to state restrictions in our domain. I notice I've got a plain x in that first fraction, so I know x can't equal 0. And in my second fraction, if I say x plus 2 can't equal 0, and we move 2 over, we know that x can't equal negative 2. So we're going to have to remember those two in our final answer. And then step 3, creating that LCM, that LCD, least common denominator. It's the same rule that we applied before. So we'll write LCM, which is fine for least common multiple. Now we've got a number 4, we've got a monomial x, and we have a binomial x plus 2. Nothing's overlapping here. This means our LCM is going to be the product of all of them. We have to make both of our fractions have that in the bottom. So step 4 is where the work takes place. In step 4, what I'm going to have you do is just rewrite that first fraction, 3 over 4x, and I'm going to extend the fraction bar. Now looking at the current denominator, it has the 4x, but it still needs the x plus 2 to have the LCM. So what that means is I have to multiply that on the bottom. And in any fraction, whatever you do on the bottom, you have to also multiply on the top. So now it has my denominator that I need. Let's go to the next fraction. It has x, and I already have the x plus 2. But now we're missing the 4 times x, our number and our monomial, which means I have to multiply that on the bottom and multiply that on the top. Okay? We're still in the converting section. So what I'm going to do now is I'm going to take my numerators and simplify them. So I'm going to distribute the 3 in. This gives me 3x plus 6 over 4x times x plus 2 plus x times 4x is going to be 4x squared over, and I'm just going to put my 4x out in front here so that they look the same, x plus 2. And that's step 4. Now that we've converted each fraction, I'm just going to slide this up a little bit here. We're going to go on to step 5, combine the numerators, which means I'm going to take my 3x plus 6 plus 4x squared and put it all over one common denominator, 4x over x plus 2. So now I'm going to rewrite the top in standard form because it's quadratic. 4x squared plus 3x plus 6 just kind of rewriting the form, all over 4x times x plus 2. That's step 5. Step 6, factor the numerator if possible. So if I have 4x squared plus 3x plus 6, what we need to do is try the 4 times 6 to get 24. Let's see, numbers that multiply to get 24, 1 and 24. Whoa, 4 right there, 2 and 12, 3 and 8, 4 and 6. Unfortunately, none of them give us 3 in the middle. What that tells me is that it's not factorable. And what that also tells me, everybody, is that we need to put the top in parentheses. Because in order for us to reduce our fraction, we have to have an exact match on top and bottom. So I know that it kind of looks like that 4x squared on top could simplify with the 4x on the bottom, but it can't because of that addition. Okay, so that makes our final answer to be 4x squared plus 3x plus 6. Nothing simplifies with that. All over 4x times x plus 2. Now, if you want to put that top in a parentheses so that you don't try to simplify it with the 4x on the bottom, go ahead. If you're okay with writing it like that and stating your domain, remember we said x couldn't equal -2 or 0 at the top. So here's our simplified answer with our included domain. And let's try example B. X plus 3 over x squared minus 1 plus 2 over x squared minus 3x plus 2. Taking a look at the denominators, they're currently unlike denominators. And unlike that last question, we have some factoring to do here. In x squared minus 1, we know that that's a difference of perfect squares. So that's going to factor into x and x, 1 and 1, and then a plus and a minus. All right, what about x squared minus 3x plus 2? Is that even factorable? Can you think of two numbers that multiply to get 2, but also add to get -3? If you came up with -1 and -2, you'd be right. X minus 1 times x minus 2. That's factoring just the denominators. Now, because we have variables in the denominator, we're going to have restrictions. If we set the first two parentheses not equal to 0, we know that x wouldn't be able to equal -1 or +1. And in that second fraction, if we set them not equal to 0, x can't equal 1, well, we already have that, so x can't equal 2 for that second one. But we already have this restriction over here, so we don't need to rewrite it. All right, okay, here we go. All right, okay, wow, all right, okay, here we go. I'm going to stop saying that. To find our least common multiple for our denominator, let's take a look. We don't have any coefficients out in front, nor do we have any monomials. So now we just have a bunch of parentheses to look at. I see an x plus 1, and there are no x plus 1s to kind of compete with it. That has to be part of our LCM. I also notice that x minus 1, we have a match right there. They're both raised to the first power, which means we're going to keep that in our LCM. And then over here to the right, we've got that x minus 2. So without knowing what x equals, this is the smallest denominator we can have with everything included. Now, step 3, let's convert. Or no, that was step 3. Step 4, let's convert. In that first fraction, we're just going to start by writing it with our factored form, and then we're going to extend our fraction bar. And also notice, everybody, I'm going to put x plus 3 in parentheses. So I'll start with that, x plus 3 over, we have x plus 1 and x minus 1, but we're missing x minus 2. Guess what? If we put that in the denominator so that we have the LCM, we're going to have to put that in the numerator. Okay, plus, we'll do the second fraction. Again, extend that fraction bar, 2 over. Now we have x minus 1 and x minus 2, but we're missing in this one the x plus 1. If we do that on the bottom, yep, we also have to do that on the top. So that's the part of step 4, converting each fraction. But the numerators, we have some work cut out for us here. We do have to FOIL in order for us to be able to combine like terms. So I'm going to FOIL this part right here, and then I'm going to distribute in that second fraction. If I FOIL the x plus 3 and the x minus 2, I'm just going to write that over here. That's going to give me x squared minus 2x plus 3x minus 6. And that would equal x squared plus x minus 6. So that's x squared plus x minus 6, but then all over my LCM. X plus 1, x minus 1, whoops, get that minus in there, and x minus 2. And if I distribute the 2 in, that should be simple enough. 2 times x plus 2 times 1, all over that LCM. X minus 1, x minus 2, and x plus 1. All right, from here, let's combine our numerators. We have x squared plus x minus 6 plus 2x plus 2. And I'm just going to combine that and then put it all over my LCM instead of having to write it twice. Let's see, I've got x squared, and then 1x and 3x, or 2x would be 3x. Negative 6 plus 2 is minus 4. All over that LCM, x minus 1, x minus 2, and x plus 1. And you can write them in any order. Oh, that's step 4. Excuse me, wow, step 5. That's step 5, combining the numerators. Step 6, see if you can factor the numerator. So now we have to factor this. What are two numbers that multiply to get negative 4, but also add to get positive 3? That would be 4 and negative 1. So I'm just going to keep going with this. 2 parentheses on top, x and x, minus 4, no, plus 4, minus 1. All over, again, your LCM of x minus 1. Whoa, my goodness, you guys, I got to write that. There we go. Okay, try that again. X, oh, I could have done the plus. Nope, never mind. What am I doing here? Oh, that's a plus right there. That's what I missed. Minus 1, x minus 2, and x plus 1. There it is. Okay, that's step 6. Now, step 7. Is there anything we can cross off? And I think I noticed right away an x minus 1 on top and bottom. And that looks like it's it, which would make our final answer x plus 4 over x minus 2 and x plus 1, comma, please include your domain in your final answer. X can't equal negative 1, 1, and 2. Wow. All right, let's try a couple more. Okay, who's up for 3 fractions? Again, just adding for now. We have x plus 2 over x minus 4 plus 2 over x plus 5x over 3x minus 1. The nice thing about this problem, if anything, is when we look at trying to factor the denominators, I have an x minus 4, a plain x, and a 3x minus 1. Nothing factors. For our domain, if we say x minus 4 can't equal 0, we know x can't equal 4. And the second one, x just can't equal 0. Now the third one, we have to do a little bit of detective work. If 3x minus 1 can't equal 0, we have to add 1. That's a plus right there. And we get 3x can't equal 1. And x can't equal that fraction. All right, to find our LCM, our least common multiple, there aren't any coefficients out in front, but I do notice that monomial x in the middle, and that needs to be included. Our 2 parentheses, because they're different from each other, both need to be included in our LCM. So we have to make every fraction have that denominator. As we go to our converting step, step 4, again, take each fraction, and like I said in that last example, if something has a plus or a minus, include a parenthesis. If we have x plus 2 over x minus 4, not only does that need the x, but it also needs the 3x minus 1. We have to multiply all of that together in the numerator. And then plus, second fraction, 2 over x. We really need to extend that fraction bar. This one needs both parentheses, so x minus 4 and 3x minus 1. I know, it's going to be so much fun. 3x minus 1. Last but not least, we have a 5x all over. There's our 3x minus 1. But now this one needs the x and the x minus 4. X minus 4. Oops, put that in parentheses. There we go. What we need to do here, and I'm going to allow you to pause the video to try it, is we need to take each fraction and clean up the numerators. So we're going to multiply, multiply, and multiply. I encourage you to pause the video, try the multiplies. In that first example, what I'm going to do is I'm going to distribute the x into just one parenthesis, and then I'm going to FOIL. In the second example, I'm going to FOIL first, and then distribute the 2 in. In the third example, I'm going to multiply the 5x to x, and then distribute it in. All right, pause the video, give yourself some time to practice that. When you're ready, press play, and we'll continue with the process. Let's see how this went. In that very first fraction, I ended up with 3x cubed minus 5x squared minus 2x. Plus, for the second fraction, 6x squared minus 26x plus 8. Plus the third fraction, 5x cubed minus 20x squared. All over one least common multiple, which is our denominator. To combine like terms to simplify the numerator, I have a 3x cubed and a 3x cubed for 8x cubed. We have a 5x squared, a 6x squared, that would be 11, minus 20x squared would be minus 9. We have negative 2x minus 26x for minus 28x. And then we have a constant at the end of 8. Whoa, 8x cubed minus 9x squared minus 28x plus 8, all over our LCM of x minus 4, and 3x minus 1. I'm going to help us out here for a quick second. The numerator is not factorable. I know this to be true. Therefore, that is our final answer, and I'm sorry. For our domain, we know that x can't equal, what did we say? 0, then 1/3, and then 4. All right, take a break from this video, and then when you're ready, we have one more example, but we're going to do a separate video for that one.